Meanwhile, when we're talking about the volume and capacity of an object, what we're looking at really is the amount of space it takes up now into that third dimension. Or you can think of getting like a third dimension from a rectangle or a square by taking it and then just stacking copies of it up there until you get a whole new units worth of rectangle, I guess. Think about it however you want to. And then the capacity of it is the amount of fluid you could fill up in there. Fluid is a very, well, fluid thing in terms of chemistry. We're not just saying a liquid going in there, but any amount of space that it takes up can be thought of in that way, where, like when we were talking about areas at the beginning, I'm not going to get too into detail here about the actual formulas for computing the volume of a shape. That's not really the purpose of what we're doing here. We're not getting into the geometry. We're just talking about the idea of what it represents and a bit on the units as well. So let's just get a quick example here for the kind of thing that we're looking at. So for this, we want to find the volume of the solid pictured, where we have 1 cubic unit and some number of them in that shape. Where here we can think of this just in terms of how many of each piece appears. That is, we've got 1 cubic unit. We don't know if those are inches, yards, miles, whatever they could be. They're just one perfect cube in there. And there are 3 rows. The rows are 2 high and another couple in there deep. That is, we have in total 18 of those boxes if we go bit by bit, counting every single one there. So in this case, the volume would be 18, I'll say, cubic units. And that's really loose notation to just say cubic units. So what we're going to do next is talk a little bit more specifically about what our cubic units really look like.